Let's review all things lines, topics from all the way back in 7th grade. First thing we'll talk about is the slope of a line. Slope is the steepness of a line, or the rate of change. It can be expressed as the rise over run. It can also be expressed as a formula where the slope equals the y2 minus y1 over x2 minus x1, and that comes from some ordered pairs, x1, y1, and x2, y2. So it's two different points, and they're xy parts. The other way we can think about this is change in y over the change in x. Now it's important to note that slopes can be positive, negative. We can have a slope of 0, and slope can be undefined. On these graphs, from left to right, graph A has a positive slope because it is going up from left to right. Graph B has a negative slope. It is falling from left to right. Graph C doesn't rise at all, but it runs forever. So this has a slope of 0. Graph D is opposite of graph C. Okay? It rises forever and does not run. So the run is 0. The problem is, okay, if I rise forever and run 0, I cannot divide by 0, so that is undefined. Okay, example 1, we want to find the slope between these 2 points. Let's use our formula. y2 minus y1 over x2 minus x1, where our points are x1, y1, and x2, y2. If I continue with the formula, y2 is 2, minus y1 is 0, divided by x2 is negative 1, minus x1 is 3. When I simplify, 2 minus 0 is 2. Negative 1 minus 3 is negative 4. My slope will be negative. 2 over 4 simplifies to 1/2. Next line. y2 minus y1 over x2 minus x1. 4 minus 0 is 4, over 3 minus 1 is 2, 4 divided by 2 is 2. The example also asks to state if the lines are parallel, perpendicular, or neither. Remember, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal means opposite sign and flipped. Let's look at our two slopes, negative 1/2 and positive 2. Those are opposite signs. The reciprocal of 1/2 is 2 over 1, so these would be perpendicular. Let's review graphing a line. A graph of an equation in terms of x and y is a collection of all ordered pairs. Remember, x is the domain and y is the range. So from a graph, there are sets of many ordered pairs that comprise our line. Let's review slope-intercept form. y equals mx plus b is our slope-intercept form. M is the slope, and b is the y-intercept. Let's get this equation into slope-intercept form. Okay, we need to solve for y. From there, we will be able to graph. First step is to get rid of our x's. That leaves me with 2y equals, notice in slope-intercept form, the x stuff is written first. So I'm going to write my x stuff first, followed by my constants. The last step to solve for y is to divide out the 2 everywhere. So y equals, let's state my slope as a single value, negative 3 halves x plus 2. 4 divided by 2 is 2. From there I can graph my line. My y-intercept is 2. My slope is negative 3 over 2. I'm always going to run to the right. So I will assign the negative with the rise. It tells me to go down 3 and right 2. Down 3, right 2. Okay, and I can do that in both directions to help me graph my line. It's ideal to use a straight edge here. I don't have one. I'll try my best. That looks pretty good. Okay, I have now graphed that line from slope-intercept form. The last thing we'll review is writing the equation of a line. We can do so with many different pieces of information about the line. Slope-intercept form will always get us started, and it'll help us find the rest of the information needed to write our equation. In order to write our equation, we need a slope and we need a y-intercept. Oftentimes we'll be given a slope and some points, or just some points, that will help us find the slope and y-intercept. We can also write an equation from a graph. Okay, so our equation y equals slope. I need to identify 2 points that are on the line. There are multiple points. Okay, to get from the leftmost point to a point on the right, take these 2 points, I need to rise 3, run 1. So my slope is 3. I write x plus the y-intercept is 5. So I've written the equation of that line in slope-intercept form. Example 2, write the equation of a line that passes through the given point and has the given slope. Remember, ordered pairs are x and y. I have a slope, I need the y-intercept. Again, slope-intercept form will get us started. Let's fill in the information we know to find the y-intercept. We know it goes through the point -2, -5. The y part of that is -5. I know it has a slope of 3, so my m is 3. Again, we knew it went through the point -2, -5, so the x part is -2. The only info I do not have is the y-intercept, so I'm going to leave that in terms of its variable b. Okay, from there we can simplify and solve for b in order to write the equation. Okay, again, I only need a slope and a y-intercept to write the equation. I had the slope, I'm doing this work to find the y-intercept. Let's simplify and solve. -5 equals -6 plus b. To solve for b, I'll add 6. So b is going to equal 1. I can now write my equation. Y equals mx plus b. Last example. Write the equation of the line that passes through the given points. My equation has to be in slope-intercept form. This time, I'm only given points. I don't have a slope. I don't have a y-intercept. However, I'm given 2 points, x1, y1, and x2, y2. That's 2 coordinates. Okay, x1, y1, and x2, y2. I know a slope formula between 2 points. I can use it to find the slope. y2 minus y1 over x2 minus x1. So my slope will be 7 minus 3 over 4 minus 2, and simplify. 4 over 2 is 2. So my slope is 2. I need to find a y-intercept. In that last example, we had a point and a slope. This example, I have 2 points and a slope. I get to choose which point I want to sub in to slope-intercept form to find the y-intercept. I'm going to choose this first point. Okay. I'm going to choose that point. I'm going to fill in slope-intercept form. My y is 3, my m is 2, my x is 2, 2. I don't know my y-intercept. Okay, let's continue here. I have 3 equals 4 plus b. Solve for b. Negative 1. I can now write my equation. Y equals mx plus b. That's all for now. We'll catch you later.